Welcome to Fundamentals of R for Biologists. This webinar is going to cover the absolute fundamentals of R and really get you started into manipulating data, cleaning data sets, and of course, loading data into R. So we're going to get started immediately. We're just going to hop right into it. So I already have RStudio open. If you don't know what R and RStudio is, that is totally fine. Just know that this webinar does not cover how to actually download R, how to actually install RStudio. I do have a free online course about that on my website, which is, well, right here. Yeah, well, what is R? What is RStudio? On the sidebar, it includes how to actually install it and the very basic fundamentals. We're not going to talk much about this, so let's get into the webinar. So here we are in RStudio. And like I said, the goals for today are to load data in, merge that data together, and then analyze it. So we'll filter out the data, we'll clean it just a bit, and then try to develop some summary statistics. These are the steps that I do whenever I start with any new data set, any new project in R. So how do we begin? Well, first, let's start a new script. So we do this by going up into the top left, new file, R script. An R script is just where we can actually hold all of our functions together. This will make it much easier for us to, well, actually know what we're doing in R, right? So often we are kind of guessing our way through R, and that's not what we want to do. So the very first step is to set our working directory. A working directory is simply where we are going to work out of. So if I go to my desktop, I have this folder right here called webinar. As you can tell, this is the folder that I'm going to be using for this webinar. So inside of the folder, I have these two data sets. We're going to ignore this R markdown. We're going to ignore this. We're just going to look at these two CSV files. This is the data that we're working with. The first is the OSU Amphib dataset. So this is what it'll look like. This is what it opens up like in Excel. This is essentially occurrence records downloaded from GBIF. It is part of the, I do have it up here, the Ohio State University Tetrapod Division Amphibian Collection. So this is downloaded from GBIF. I have another webinar where we discuss how to download data from GBIF. And then the second data that we're working with is going to be something called the Amphibio database. This is a global database for amphibian ecological traits. So these are the two data sets we're going to work with, and we're actually going to merge them together at some point in this webinar. So we have placed those two data sets, the Amphibio and the OSU Amphib data sets, into our working directory. Again, this is where R is going to work out of. R doesn't know where your files are. You need to tell it where its files are so that it's not searching every file in your computer hoping to find the right one. So the easiest way to do this, if you're on Windows, I believe this also works for Mac, but don't quote me. This is going to be a Windows-focused tutorial. You can click into your folder. So this is your file explorer. You navigate to whatever folder you're working with. And if you click inside this address bar, it'll give you that file path. So in this case, this file path, just a series of instructions for our computer. This is saying, hey, look in the users folder, look in Dill.j, look on the desktop, and look in the folder called webinar. We're going to copy this, and then back in R, we are going to go into our script, and we are going to type out the command setwd without typos. First command, we're already starting with typos. That's the nature of R. Setwd stands for set working directory. And all we're going to do is inside of quotation marks, we're going to paste that working directory that we copied. Again, this is just from the file. This is just the file path from this folder right here. We just grabbed it right here. We have one more thing to do. We need to convert these backslashes to forward slashes. This is a step that is often missed by newcomers in R. But once we run this, now we just need to run this code. I run them using the keyboard shortcut Control-Enter, but there's also the Run button found right here. So I will select Run, and what you'll see is down in our console, which is on the bottom of the screen. If I run, you see it ran the command setwd right down here. So anything in the script gets sent down to the console to run, and we can confirm that our working directory has been set because right here at the top of our console, we can actually see the working directory. And in fact, if we click on this little arrow, it will open up the working directory folder on the right-hand panel underneath Files. So this is the working directory. This is how to set it. I find that even those who already know how to code in R don't know how to set their working directory, so this is what we'll cover. But this is just the first step. So now R knows where to actually work inside of our scripts. But let's load our data in. So how do we load our data? So again, we're working with this data right here. We want to load in both of these two data sets. They are both CSV files. These are comma separated values. This is a very common data type. And so we know they're CSVs because they both have this file extension .csv. Your computer might be hiding the file extensions. So this is something you might have to enable on your device to see what type of file it is. However, you can also look at the file type. So to load this into R, we are going to use a very simple function, read.csv. And so how does this work? We read data into R. We want to read it so that we can understand it. So we're going to assign it to an object. Again, this is covered in that just getting started with RStudio, kind of what is an object. So what we're going to do is, since we have two different objects, we have the OSU data frame, we're going to call it DF. A data frame is essentially a table. It's similar to an Excel table, but that's just the lingo we use in R. To assign data to this data set, we are going to use the arrow. Think of this as data is flowing into the object, and then it will be stored. And again, we're going to use that read.csv function, and all we need to do is inside of parentheses and inside of quotations, we need to list out that file name, okay? Exactly as it is written, including that file extension. So if that file extension is hidden on your computer, you will need to make sure you include it. So here, osu_amphib.csv, we need to make sure we include any capitalizations, any punctuations, amphib.csv, and that file extension. We're going to run this. I'm going to use that keyboard shortcut Control-Enter again. And what you'll see is over in our environment on the right-hand side, top right-hand side, we now have this data set. If we click on this arrow, we can now get a preview of the data. So here we see that all these records are in the kingdom Animalia, in the phylum Chordata, and the class Amphibia, because these are amphibian records, right? We can also click on this table, and it will show up as a table in our source pane. This is that top left pane where our script is held. So this gives us an idea of just what the data looks like. Just know that you can't edit the data on this view. You can just view it. So we now have one data set in. Let us get the other data set in. I'm going to show you the best part of coding, why we do coding, and it's simple. It's because we can copy and paste things. So if we want to be very, very lazy, what we can do is we can copy our data set from my example that I'm working with here. So here we have a new object. This is just going to be amphibio. We're going to read.csv, and we're going to get the file. Again, this is named exactly as it is in that folder, including the underscores, the capitalizations, and that file extension. We're going to run this, and I'm going to put it on the environment feed first so you can see it. What happens when we run it? We now have amphibio right here. Easy. So this is the very basics of how to get your data into R. There are some ways to do it via the GUI where you can just click buttons and say, load this data, here's the separator. But by doing it with code, it makes our code a lot more reproducible, and we can make sure we're getting the exact file we need instead of hoping we remember which file we selected with that little GUI interface. Okay, well, great. Now our data is in R. What do we need to do? So I teach R using a package. I use the package Tidyverse. If you're learning R, learn it with Tidyverse. You don't need to use base R for everything. Learn it with Tidyverse. I promise you'll have a much easier time. So let me explain what Tidyverse is. So a package is simply a collection of functions, and the Tidyverse package is a collection of other collections of functions that are specifically designed to make data analysis, data cleaning, and data visualization much, much easier. So I already have Tidyverse installed on my computer. If you do not, you will need to use this function here. It's called install.packages and then in parentheses, in quotations. You'll see this is a common trend, parentheses, quotations. You just need to type out Tidyverse. If you run this function down in the console, it will start to install the package for you. Mine's already installed, so it has a very different message than if you installed it from scratch. But installing a package is not enough. We also need to load it into our R environment. Think about installing a package like getting a book from the library and putting it on your bookshelf so that you can use it later. And then when we want to load the library, which we'll do with the function library, when we want to load the package, we'll do it with library. We want to take that book off of the library. We want to use it. So we type in the name of the book, Tidyverse. Easy. And then we make sure to run that script as well, run that little bit of code. So this is the very basics. Just one thing to note is that when you load the package, you don't need to put it inside of quotation marks. But when you're doing install.packages, you do. There's some minor technical reasons for that, but thought I'd leave that up. But anyways, now we have access to all of the functions inside of Tidyverse. So we can actually look at them all by typing out the name of the package, doing 2 colons, and then here we can start to see all of the functions that are included with Tidyverse. Tidyverse, again, loads multiple packages. So for example, one of them is the ever popular ggplot2 package. Here we can see all of the functions that are loaded with ggplot2. We actually did a whole webinar about how to plot with ggplot2 if you're interested in that as well. So great. We now have loaded Tidyverse. We have our data sets inside of R. We've set our working directory. Well, let's actually, do some data. Let's actually do something. So what we are going to do is first, we have a lot of columns inside of these data. In fact, you can see here that the AmphiBio has 38 variables, otherwise 38 columns, and the OSU data frame has 50 columns. So what we're going to do first is we are going to use the select function. And what we're going to create is a pipeline. A pipeline essentially takes an object, does multiple steps to it, and then provides you with some type of output. And we are going to do that first with this OSU dataset. So let's type out the name of the dataset. This is going to be OSUDF. And now we are going to create a pipeline. For these pipelines, you need to have Tidyverse installed. And all that this pipeline is it's going to be the %, this little greater than less than symbol, and then another %sign. Let's actually make this just a tiny bit larger. Tiny bit. Perfect. So we now have this. What this is saying is that, hey, take the information within OSUDF, and then I want you to feed it to some other function, some other process. We're going to put this on a new line. Pipelines can go to new lines. All you have to do is hit enter. And we are first going to use the select function. What the select function does is it selects columns that we want to use. So let's say that we are only interested in analyzing a few of our columns. Let's say we want to keep the order of the amphibians. Maybe we also want to keep some other taxonomy like family, genus, and species. And let's also get that geographic information from this data set. So we know that this geographic information is called decimal latitude, and this is decimal longitude. If you're wondering where I'm getting this information from, these fields, these are coming from our data directly. So if we look at the correct data set, OSUDF, we see that we have this class, order, family, species, and we also have decimal latitude and decimal longitude somewhere in this data set, right here. So if you're wondering where this is coming from, it's coming directly from the names of the columns. Notice that we are making sure to actually spell everything correctly. So if there's a capital L, we also include the capital L. So if we run this bit of code, let's go down to the console so we can see what happens. What we find is that it outputs only that data set with only the columns we selected. So that's all select does, is it just selects columns for you. So it filters out the data set. This way you can get a very focused view of your data. Well, there are some other issues in here. In fact, if we look through our species long enough, we'll find that, well, some of these records are missing the species data. We don't want that. We want to make sure that all of our records include the species. So what we're going to do is we're going to filter out records with blank species. And if you're curious about these downloads, if you're curious about where to get this information from, there will be an email with a handout that includes all this information, and these data sets are 100% downloadable. So if you RSVP'd, you will be getting these emails. And if not, they'll be on the handout page, on the webinar recap page once we finish getting this up, and the link will be down in the description. Okay. So let's filter out our data. So again, we're going to remove species that are blank, and we're going to use that filter function. So a couple things to note. One, let's make sure we're actually looking at the right screen. A couple things to note. One, we've added a new pipeline. So this is now saying, hey, we take this information from the OSU DF, we are going to select the columns we want to use, and now we're going to feed that data into filter. So we're feeding this data right here. Only this data set with these, 1, 2, 3, 4, 5, 6 columns. Okay, we're not feeding it the full data set, only the ones that has been selected. So how do we filter out this data? Well, what we're going to do, the filter requires some type of logic to it. Let's say that we only wanted to find records that were, let's do genus to make this example a little bit easier. Let's say we only wanted to find records where the genus was equal to Hyla. Okay, we only want to get records where the genus is equal to Hyla. And if we ran this, go down into our console, we can see that it filtered out the records that only have Hyla. Okay, and we did this via a logical operator. So here, the genus is equal to Hyla. We have to use 2 equal signs for this logic. That's the way R knows it's logic and not trying to say that you want to assign a value to a data. So you'll just use 2 equal signs. But this is not the information we wanted. We want to remove those blank species. Well, the inverse of equal is going to be not equal. And we specify that just by adding making it a exclamation point equal sign. This means not equal to in R. And we want to do it over the species column. And we want to do it where records are blank. So how do we define blank records? Well, we feed it this string with nothing inside of it. That is a blank record. Just note that this is not an NA record. That is considered a different type of data. So this is where there is truly no information, not even NA, inside of the records. So if we run this, let's go back down to our console and try to figure out, did this work? Well, the best way we can figure that out is by scanning our species column where we know there was a blank, and we're not seeing that blank any longer, and it appears that we have retained all of the data. So again, this is just removing records with blank species. This is something that you will have to do often. And that's really it. One thing we are going to do is remove duplicated records. We'll do a little bit of this here. So filter, we'll just add a second filter. You can actually put them in the same function, but we'll do it as separate filters for the time being. So new pipe filtered, and we're going to go for records which are not, again, adding the exclamation point, duplicated. And inside of there, we'll just add this little period. This is the period signifies that we're taking the data from the prior functions. We won't cover this too in depth. This is inside of a few handouts that I have, but yeah. So what is the last step we have to do? We now have to assign this data to a new object. We have to say, oh, we cleaned this data set. Let's actually name it appropriately. So we'll use another arrow. This one's pointing to the right. I like to assign at the end of my pipelines because it makes more sense. You know, we started with OSU data DF, we selected some columns, we filtered out species, we filtered out duplicates, and now we want to assign it to a new data set. So what we'll do is we'll just call it OSU DF clean. And if we run this, we can now see over in our environment, we have a new data set right here, OSU DF clean. We have removed about 1,400 records. That's from data cleaning. So those were duplicate records or ones that had a blank species. And we only have 6 variables. Awesome. So now we were able to filter the rows and filter the columns using really simple functions in R. So now let's do this for this Amphibio dataset, and we'll go through it a little bit quicker since we covered pipelines, filtering, select, etc., etc. But we'll introduce a new dataset. So here we go. We start with Amphibio. Let's give ourselves some space. We add a new pipe, and then what we're going to do is select the columns we want to use. So we'll do select. And for this one, again, we would look at the data set. I already have a list of columns that we want to use. So let's take the species column. Let's take, let's take terrestrial, aquatic, AQU, ARB, body mass. And I'll explain what each of these are shortly. Body size in millimeters. Okay. So these are the variables which we wish to study. The first one is just a species column, right? We just want to know what species we're working with. Terrestrial, aquatic, and arboreal are binary variables. They just contain a 0 or a 1, and all they say is, hey, is this species terrestrial? Yes or no. Is this species aquatic? Yes or no. Is this species arboreal? Yes or no. And then we take the average body mass for the species and the average body size. So these are some great ecological variables. These are actual characteristics of these organisms, and we want to use them for our study. But maybe you are really interested in using that body size metric, but as centimeters. You want to use them as centimeters. It just makes more sense for your study, for your analysis, whatever. Here, we can actually mutate these columns in order to make them more usable to do this. And we'll use the function mutate. Who would have thought? So mutate allows us to just mutate all of the data in a column. And it has a few very, very easy to understand steps. First, we need to specify the column where this data will go. So if you want to make a new column, all you need to do is type out the name of a column that is new. So in this case, since we're converting millimeters to centimeters, we're just going to call it body size cm. You can overwrite columns if you so desire. So if you want to mutate it again later and you call it body size cm, it's not going to make a new column. It's going to overwrite that first column. And so now we need to give it the data that we want to put inside of this column. So first we'll do an equal sign, single equal sign. Again, this is not a logical operator. We're assigning data to this column, so we're going to use a single equal sign. The logical operators are for double equal signs. But now, what are we doing? What data are we putting into body size cm? Well, how do we convert millimeters to centimeters? We divide millimeters by 10. So that is what we are going to do. Body size millimeters divided by 10. That's it. And maybe this is all we want to do for our data set. So what we'll do is we'll assign it, we'll add that arrow, and we'll call it Amphibio clean. Amphibio clean. And let's run this and actually investigate if that mutate function worked properly in our environment. So here we go, Amphibio clean. We didn't filter any data, so we have the same number of observations, but we did select our column, so we only have 7 columns. Let's look at a preview of our data. Well, look at this. Body size millimeter was 31. Now in centimeters, it's 3.1. Millimeters was 50. Now it's 5. So it appears that our function worked. That really, really simple mutate function, again, where all we did was take the body size in millimeters divided by 10, and then we assigned it to this new column, body size cm, all within the mutate function in our pipeline. So this is all the pipelining we're going to do for these analyses. Because this is what you will always be doing whenever you're cleaning data, whenever you need to get data into R. Almost all of my data pipelines start with selecting the columns I'm going to use and filtering out records I'm not going to use. Maybe a few mutates where needed, but that's really it for a very basic data cleaning. So we realized along the way that you know, this data is great, but we kind of want to connect them, right? We want to have this occurrence data where we know a species was found at a particular location at a particular time, and we want to attach to it all of this amphibio data. We want to say, oh, well, this species is found here. It's a terrestrial species. It's aquatic. You know, its average body size is this. So how do we actually merge these two data sets together? How do we merge amphibio with this OSU occurrence data set? Well, we're going to use that function merge. So merge allows us to merge two data sets together. And what we need to have is a consistent bit of data between our data sets that it can merge on. In this case, we're going to use species. Okay, we have on that occurrence data set, we have species for, you know, hey, this species was found here. And that amphibio data set, we have species for, yeah, this species is aquatic and arboreal and it gets super large or whatever. So we are going to combine on species. So let's add that in, and we're going to work with our cleaned data sets. So first, let's add in our data set. We just need to add in 2 for merge. So we have OSU underscore DF underscore clean. This is our cleaned data set. We're going to add a comma, and now we're going to merge it with amphibio. So amphibio clean. I wish it were that easy. I wish that's all we had to do, but of course we need to specify by what columns we are merging. So there is a problem between these two data sets. Normally we could just write out, okay, well, by is equal to species, right? That's what we want to merge. And if we run this, we get an error in the console. By must specify a uniquely valid column. The problem that we have in our code is that our data sets spell species slightly differently. In fact, if we look at our environment, when we have the amphibio clean data set, species is spelled with a capital S, but with our OSU data set, species is spelled with a lowercase s. This is a very common data issue. It happens all the time with biological data sets. Luckily, merge can account for that. And all we need to do is just specify the by.x and by.y. X is going to be the first data set in our function. So in this case, OSU DF clean. And this one does have a lowercase s for species. And then for the amphibio data set, again, we're going to copy and paste, but we're just going to type in by.y. That's it. Y is going to be this second data set. So that's all we need to include. And now we just need to make species a capital S. If we run this code, well, look at this. We actually get an output in our console. And what you'll see is that for every record, we now have the biological data included. So let's assign this to a new data set. We're going to call this DF merge. That's usually what I call my merge data sets. So again, we're using the arrow operator to assign it to an object, merge all this data that we're producing. And if we run this in our environment on the left-hand side, we now have DF merge. And we can see, well, look at this data right here. For every single record that we have, we now have the associated biological data. This does repeat, and that is fine. That is completely normal because we have multiple records of, in this case, Acris crepitans, your good old cricket frogs. We have multiple records at different longitudes, different latitudes, different locations, and so, but the species is the same, so that's why this data is the same. This isn't a mistake. This is what we wanted. This is what we expected. So you'll notice, though, if we look at our environment, we have different numbers of observations. So DF merge is 3440, even though the OSU dataset was 3555 and the amphibio dataset was 6776. Merge by default will exclude records if they're not both in the datasets. So what could have happened in this case is that the OSU dataset had taxonomy that was not in the amphibio dataset, so it was just removed. There are settings you can do inside of merge to not remove that data, but for this case, we're using an example where we would want to keep all of the data and exclude the data that is not equal. So just keep that in mind. Okay, now what we're going to do to round off this webinar, it's already been half an hour, but we've already accomplished a lot, right? We've loaded in our data, we have a new data set, we've actually cleaned it a little bit with select and filter and mutate, and now we've even merged our data sets together so that now we can actually do some really, really, really simple analysis pipelines. So what we are going to do, this is my favorite type of pipeline because it is such a commonly needed style of pipelines that I think every biologist needs to know. So let's start with this DF merge. And what we're going to do is we're going to do group by and summarize. These are really, really useful pairing of functions that you can use. So this is going to be another pipeline. This time it's going to be an analysis pipeline. We're not doing any data cleaning. We're analyzing our data. And let's say we really want to know what is the mean of body mass? What is the average body mass in our study? So let's start with just summarize. Summarize does what you think. Summarizes data, right? So let's say we want to look at the mean of body mass in grams. What we find, if we just run this on our data set, we run into an issue. We get an NA value. Well, unfortunately, there are records of body mass inside our data frame. So if we go into our data frame preview, and if we sort by body mass, let's see, maybe we need to do the other sort. It's going to be at the bottom, isn't it? Yeah, here we go. We find that we have a lot of NA values. Well, this is a problem. So we don't want to filter out these records from our initial combining of the data sets. We want to keep them in because there's still really good data here. We still have body size. We still have terrestrial and aquatic. So we don't want to just remove this data. But for this particular analysis, we can do that just for a moment. It won't change the underlying data. And all we'll do is just remove those NA values. How are we going to do that? We're going to do that with a filter, just like we did earlier, just like we did when we cleaned our data. And so we're going to use that is.na function. I mentioned it very briefly. How do we handle NAs? So what we're going to do is we're going to filter out records, and we're going to keep only the ones where it is not an NA value for body mass. That's it. So if we run this record, we can see in the console, we haven't attached it to mutate to summarize yet, but we've kept almost all the records. We have only records now that include body mass. And so let's connect it on our pipeline. How do we do this? We just add another pipe. That's it. So now what this very simple pipeline is doing is saying, hey, take this merge data frame, filter out the records where body mass is not NA, and then summarize the average. And then what do we get down in our console when we run this? Boom. The average body mass in our data is 73. Cool, great. Pack up the bags and go home, right? Let's take this one step further. And the way we're going to do that is via the group by function. This is seriously the most important step of this webinar. I believe this is the most important information to make very quick summary statistics. And so in our pipeline, after we filter, but before summarize, and all we're going to do is we go into our code, and let me just do a live recreation of that. We have the data here, and now we're going to hit enter, go to a new line. So now we're adding in a step before summarize. What we're going to do is we're going to group by. What group by does is it groups your data according to some column. So you take the column and then you're going to group it all according to all the unique values inside of that column. So let's say we want to get, well, we know what the average body size is, but we want to know the average body size between different families of organism. So we're just going to type in family. We're going to add another pipe. So now what this little pipeline is saying is we're going to take the data set, we're going to filter out records where body mass is not NA, we're going to group it by all of the unique values in our family column, and then we're going to get the average body mass for each of those groupings. So for every family, every frog family or amphibian family, we are going to get the average body mass of our data set. Let's run this code, and then in our console, we can see that it did exactly that. We now have all of the families and their average body mass, okay? So we can see that the ambistamids, those mole salamanders, have an average body mass of 30.6 grams, right? We can very, very easily see that the rainids, right, your true frogs, have a body mass of around 129, and then you have your sirens, which are just a kilogram. So this is a very, very easy pipeline, and it is very, very adaptable. Say you were really interested in only looking at the genus. Okay, cool. Well, you just need to change that one bit of code, and now you have it by genus. Maybe you really are interested in changing it by order. Okay, cool, done. I did not even include order inside. Oh, it's a lowercase o, that's why. There we go. Well, now look at this. We can see that on average, the frogs are heavier than the salamanders, right? Anura being frogs, Caudata being salamanders. And maybe you want to look at a different data set, right? Maybe you like this order, but maybe you want to see body size CM. I mean, after all, you did change that variable. Well, let's change our filter. Let's exclude NA values. So body size CM, and then we're going to copy this down here to summarize, run it, and then, well, look at that. We now have body size in centimeters. So again, all of this is able to be done with a very, very simple function. You could absolutely include this filter up earlier in the data set to filter out later, and then all you need to do is group by and summarize. If you want to change the mean, maybe you want to change this to the standard deviation or the range or the maximum value or the minimum value. You can absolutely do that. Group by and summarize is probably the most useful function pairing in Tidyverse as we use it very often. Okay. So this is actually it for our webinar material, but I do want to keep your attention for 1 second because I have just finished a massive, massive revamp of the courses on the website. So what normally was a Fundamentals of R for Biologists course is now a program. Essentially, all of the modules have been split up into individualized courses so that if you just need to look up something about how to do simple data manipulation, which is a lot of what we covered here, you can now just purchase that module, or you can get the full program. This is also true for our Fundamental Biostatistics course. But each of these, for example, this is Getting Started with R&R Studio. This one is free. They all include a video lesson and accompanying text with links to more, as well as quizzes and mastery checks to cement your understanding. I am going to stop with the self-promotion here, and now it is time for open questions and answers. We have the floor. This is the time for you to get any of your questions out, and if you're interested in anything that we've covered here, if you're watching on the recap, the links will be down in the description, including courses, data sets, and also the recap itself. So yeah, and yeah, that is it. So let me go back into, we'll keep this up because I like the way it looks. But yeah, so this is open Q&A time. So if you have any questions about R, any questions about something we covered, if you just want me to recover something again in greater depth, this is your time to ask. Then we'll pull this over here. Sometimes the comments don't transfer over. And if you're curious, if you did tune into a last one, like a previous Fundamentals of R for Biologists webinar, we used to cover how to plot in ggplot2. We've actually pulled that out into a completely different webinar that we just did the other week, so that way we can spend a little more time on it, and I'll link it on the recap somewhere around here. And while questions are percolating in, let me see if I can very quickly show you one of my example Tidyverse scripts. So you can see precisely what an R script looks like in practice. In practice, there we go. That's the word I'm looking for. Boop, 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 boop. Let me do a. I'm gonna go into my personal projects. Ecuador frogs. Ecuador frogs again. Think this redo will show it well. In fact, it doesn't. Yeah, so there's a really good question about once you create these new data sets, can they be downloaded into a different file format like Excel? Absolutely. So if we open up R, let's say we wanted to export this merge data set that we have, so this df merge data set. Let's say we want to send that out to our working directory. Well, remember, when we got our data in, it's going to be this read.csv, right? So, you know, I always think about it like a book. You want to get an information from a book. What do? You read the book, right? So R is wanting to get information. So now, hey, what is the opposite of reading? Well, we're going to write the data. So we want to put information somewhere else. What do? We write it into a book. So what we'll do is write.csv. This is going to be if you want to write that data as a CSV file. And what we're going to input are two arguments. We're going to input the actual the data that we want to send somewhere else, and we're also going to tell R where to send it. If you're in your working directory and you just want it in the working directory, you don't need to put that file path. But I'll show two examples of that. So let's say we want to do this, write merge. What we need to do for file is we need to put the name of the file. So let's call this our merge data .csv. You know, include that file extension. So this is what it's going to look like in our working directory where this saves. So I'm going to pull up the working directory. So this is, just so you can see it beforehand, just has these two data sets, some R stuff, and then the R Markdown, which I am using to for this webinar. So if we run this, we now see in our working directory merged data. So this is the merged data set. This is probably the easiest way to get it into Excel. You can make it in multiple different formats as well, but that's by far the quickest way of doing it. And then let me just cover something I really like to cover, our best practices for data cleaning. So this is a file structure that I use for literally all of my projects. So I'm not the best at it, but here's one for my master's project. So I keep everything as scripts, outputs, inputs, and data. So all my raw data goes into like the data folder. All my scripts go into the scripts folder, and then inputs and outputs. The reason I'm showing you this is because we can create this in our working directory. So let's say we want to have an outputs folder. And let's actually say within that outputs folder, we want to have two folders. So we'll call one visualizations, and then we'll call another one data, right? So let's say we want to put that merge data set that we just made inside of this data folder right here. All we need to do inside of write.csv are include some forward slashes. This way you can actually specify to R which folders it needs to go into. So outputs, data. Let me make sure we don't need that first one. There we go. So we ran this, and then now inside of this data folder, we have our data. So outputs, data, merge data. So this is something I use a lot to help keep myself organized. Usually in R at the end of my script, I just have a big thing that outputs all of my data, all of my analysis results, my visualizations into this file structure. And it's super easy once you set it up, because now it's something I can copy and paste to all my other projects, and it works really well. So yeah, you can absolutely just do write.csv. That's almost always what I'll do, and CSV files are a little bit easier for data stuff in general. Like, definitely get comfortable working with CSVs if you can instead of Excel. Oh, I'm happy this helps with the analyses. I understand like 90% of the struggle of R is just understanding. Oh, so really good question. Why did it not require the entire file path, but only from the output in the data folder? That is the advantage of working inside of your working directory. So this is something that is really useful with R, is that it's always going to assume that you're working out of your working directory. It is the exact same reason why we did not have to put all of this before these file names. R is going to only look inside of that working directory, and it can only look deeper into it. It can't look at the desktop, for example, like our working directory, again, we'll look at the top of the console to remind yourselves, is that it's inside of this webinar folder. So R is not going to search for desktop. It's going to just look in webinar. So if you have additional folders in webinar, like we do here, it's going to just look in here. So that makes it way easier for you to code. It also, of course, makes it faster for R because it doesn't have to look through all of your folders. And the benefit of using that input-output structure that is consistent across all your folders is that if you change your working directory, like let's say you move it to a new folder. I had to do this recently when I migrated from OneDrive to Google Drive, right? All the folders now had different file paths. All I had to change was the working directory on my scripts. I did not have to change anything related to reading the data in, related to exporting our data, because that file structure was the exact same, just had to change the working directory. So this is sort of setting yourself up for success 3 months down the line. Current Dillon is very happy with past Dillon. So that's kind of what we shoot for, right? But that's a good question. I know working directories and file paths, when I was teaching biostatistics at the university, that was by far one of the most confusing elements for my students. So I actually used to cut it out of this presentation, but I realized how many people, I mean, no one really teaches it to you. I think that's the problem, right? You're just kind of expected to understand what a file path is. All right. And then, yeah, I was also trying to find oh, here we go. So here is a really good example, actually with the writing. So this is something that I had for an old analysis of mine. Not even that old, we just submitted it. So this is an example pipeline. So they can get much fancier. And this does a lot of information in a dense way. So this is going to be selecting a specific set of columns. I don't know why I didn't use select. I'm sure there was a reason. A conditional mutate. We're going to group it by site. We're going to summarize the number of individuals captured on each site. We're going to remove a column, transpose the data set, convert it to a data frame, and then write.csv, right? So again, consistent. This is just a random project outputs. It instantly goes to the outputs. This won't work on our data set. But working with these pipelines and thinking about it in terms of this is the steps we need to do is just a much better way of working with your data, because that's how you think about it logically anyways, right? You know that you're selecting some columns, you're going to filter some stuff, you're going to remove some records, you may need to manipulate the data in a way. But this is really nice because later on, you're probably going to have to do the same data manipulation on a new data set or an updated data set. And yes, so all of these webinars are up on YouTube. You could view them. We make sure to go back and cut out some of the awkward like starting time, ending time, and then we add chapter markers for everything. So this one will be saved. It's available now, technically. The way YouTube does things, it's just like automatically there. But I also put them all up on the website. So let me show you that really quickly. All of our webinars, let me make this small again, including the upcoming webinars, we do put them up here. But we include all of our webinar recaps on the website. So if you want to go into, I'm realizing this is not entirely correct, but say we go to how to access biodiversity data, you will find the full webinar recap right in here. So just as an example, let me pause this. We need to fix a few things, or my data is just not loading. But yeah, anyways, we include more information, and we also include handouts for all of our webinars. So if you ever want to view any of them, they're all here, all on one location, as well as on the website. And then just so that you can see this better, if we open this up in YouTube, we do include chapter markers at the bottom of every single one. So if you want to hop around, a little bit easier. Like this section is covering common issues and data flags, but maybe you're way more interested in how to use GBIF data, right? So yeah, long-winded answer for just saying yes. And we need to figure out why comments are not showing up on the website. That's a new one. They should be. They should be. Or chapter markers. Apologies. Very weird. Oh well. Step by step. And this one will be up on the website probably a little faster than the others, just because I don't have to make a handout. We already have one made. So I'm hoping to get 2 or 3 webinars up by the end of the day. Recaps up by the end of the day. But unless there is another question or anything else, just make sure to check your emails. I'll be emailing out every Wednesday. We have the newsletter now, so that kind of sums up this webinar, sums up our future webinars. But I'll also be including links to these 2 data sets. So if you want to follow along yourself, you absolutely can. They'll also be up on the webinar recap page. I just haven't. That usually takes a little bit longer than the newsletter, right? But yeah, that is it. So stay tuned next week. We do have another webinar. I believe it is the phylogenetic endemism webinar. Trying to figure out where we put that. So yeah, understanding phylogenetic endemism. This is a topic that I find incredibly fascinating. It's critical to my master's research. It's really just talking about patterns where taxa are geographically isolated, but in terms of their phylogenetic diversity, and it can reveal some really impressive things about taxa. So same time next week, next Tuesday, 10 a.m. Pacific time, we will be having another webinar. Same thing. Everything will be on the recap page, but if you want to RSVP, you can. But thanks, y'all. We will keep doing these, and thank you for learning adventurously.